Due to reprimands and circumstances, the recordings will not be public on YouTube anymore. To get parts 2, 3, and 4, visit our blog. The link is in the description below, but still subscribe for updates on new class recordings uploaded. The videos will from now on be private, not public, so you will still receive notifications on newly recorded classes but can only view them via the blog link below. Thank you, and don't forget to subscribe.
I want you to have your writing material by your side. I also want you to have your pen by your side, because at times we speak beyond the content of the slide. So I want you to be very, very attentive. Okay. So I'll be talking about neurons today. Neurons. That's what we are talking about today. And today we'll talk about definition of neurons. We'll tell us what neurons are. We'll talk about structure of neurons. We'll talk about parts of a neuron. We'll talk about properties of neurons. We'll classify neurons and we'll summarize. That's our agenda for today. Neurons are commonly referred to as nerve cells. Of course, you know, for you to have an organism, we need to have, you know, the most rudimentary aspect of living beings, which is the cell. Combination of cells will make up tissues. Combination of tissues will make up organs. Combination of organs will make all the organs in the body, they form systems. And when you now look at systems in the body, the locomotive system, the digestive system, the reproductive system, the cardiovascular system, the respiratory system, the muscular system, the nervous system, a combination of all of that to now make up a human body. Now, of course, you know that by virtue of what I've said, neurons are the basic structural unit of the nervous system. And of course, the nervous system, I have told you during a couple of lectures back that it's what controls in the body. So we quickly have control of what we do and a major definer of our behavior. The answer is yes. But yes to an extent. Yes to an extent, because even the activities of the endocrine system, they are also controlled by the nervous system through the hypothalamus. That's something we call the hypothalamic pituitary stalk that link the nervous system with the endocrine system. And through that mechanism, we have what we call feedback, positive feedback mechanism and negative feedback mechanism. And through those mechanisms, the nervous system controls the activity of the endocrine system. So that's why we do say that even though the endocrine system plays a major role, yet the nervous system is still, the super controller, because it also controls the activities of the endocrine system, and directly and indirectly to a large extent. So neurons are organized to form complex networks that perform the functions of the nervous system. So when we are talking about the work of the nervous system, functions of the nervous system, it's the neurons that are at the bottom of it. Just like your engine in your car, it's instrumental to whether that car will run fast or will not run fast. So that power resides with the engine. Okay. So apart from this, we also need to know that neurons are organized to form complex networks that perform the functions of the nervous system. When I say complex networks, in other words, we have been researching and we are still researching to be able to understand the intricate details of how neurons do their work. Even when you do craniotomy, craniotomy is a surgical procedure to open the cranium to gain access into the cranium. And of course, within the cranium, you I mean, within the skull, you have the cranium, and the cranium is the cap that actually, envelopes or covers the brain. So all those anatomical and physiological arrangements, they are very, very instrumental, and and knowledge is still expanding because we keep researching each day to know sufficiently well about why nerves are the way they are in terms of anatomy, and also to have complex details about how each of those things, how they affect functioning. Of course, each neuron consists of a cell body. Each neuron consists of somebody is distracting us. Calling you Akindipe. Don't raise your hand at the moment. And please just be calm and let's go into this lecture. Don't disturb, don't distract. Okay? So somebody's my voice is cracking. Is it still cracking? It depends on. Hello? Can you still hear me? Can you hear me? Can you hear me? Can you hear me clearly? Somebody said not well. Okay, let me clearer reception because I want you to hear me very, very clearly. A lecture like this, I don't joke with because it's the foundation for very many other things that we need to discuss. Are you able to hear me? Is it better? Is it getting clearer? Hello?
Yes, sir.
Is it getting better now?
Yes, sir. It's getting clear.
Okay. Okay, thank you. Okay, so let's continue with the class then. So each neuron consists of a cell body and its processes. When we say a process, they mean extensions from the main body. So that's what we call a process. So each neuron consists of a cell body, and apart from this, of course, many dendrites. So when we now have bundles of axons that are bound together, these are the things we call nerves. I'm still introducing, but of course the neurons cannot divide, even though they have nucleus, but they can really divide. And that's one of the reasons when one suffers an injury to the spine, breaking the spinal cord, many times the individual becomes paralyzed and can no longer do the work beyond the level of the trauma. So because the cells around that area that got traumatized may not be able to replicate, may not be able to divide, may not be able to grow back. And that's one of the reasons why accidents, trauma, injuries to nerves, to the spine, and many parts of the body could translate to paralysis. Okay. So, but for survival, for nerves to survive, they need a continuous supply of oxygen and glucose. And of course, this is very clear because the oxygen will be necessary for bringing power, energy to the cell, whereas the glucose is what will be utilized to form ATP, adenosine triphosphate. Okay. For survival, they need supply of oxygen and glucose. But unlike many other cells, neurons can synthesize chemical energy, ATP, only from glucose. That's one of the reasons when you are reading, chances are that you get hungry a little more because you are breaking down glycogen to glucose, because you are doing the